G'day. In this series of videos, we're combining Psychopy and Python programming to create the line-bisection task. Now, if you haven't seen the previous videos and you want to see how we got to creating pretty much a working program, then stop this video here, go back to the start and work your way through. Now, there is a warning. I do take quite a while to get to this point. Okay, and so if you're after something nice and quick, and if you know a lot of Python programming already, then this is probably not the video series for you. What I'll probably do is do a really super quick one right at the end of recording all these videos. Okay, but if you're not quite sure on how to approach Python programming or Psychopy programming, or understanding how to read the APIs and the reference manuals, and you like things to be just a little bit slower, then this is probably hopefully it's a good pace for you. So what we've done up until now, if you can remember, is we'll just run this program. So we'll go Python 3 line task.py. And so what we've done is we've created some GUIs which will pull up the information so we can set up the experimental ID and the experimental date. And so that's the GUI there. And we'll go AG and let's make me 35, okay? And you click OK. And then the next thing that comes up is where do we want to save it? And this is going into the same folder as where we want to select, so we can customize this or totally customize this. We click save, and then the program will then wait until the subject presses enter to start. And then if we hit enter, then we see the fixation cross, then the task, and then the subject hits either F or J to complete the experiment. Okay, now I'll just quit out of that by pressing Q. And what we have at the moment is the ability to only do 4 trials. But remember, when we pulled out that information from the Kim et al. Paper back in the first video, they did 4 blocks of 40 trials. So all that we can do at this stage is do 40 trials only. And the other thing is that we can only the subject doesn't know whether or not to do the longer or the shorter task. Remember, you ask the subject which line was longer, or which line segment was longer. If they thought it was the left segment, then they'd press the F, or if they thought it was the right segment, then they'd press J. So which segment was longer? And then in some of the blocks of trials, we'll then swap over and say which line was shorter. Okay, and then they were counterbalanced. And so there's 4 blocks in total, 2 of which were asking the subject to make an estimate on which they thought was longer, and 2 of those blocks on which were shorter. Okay, so we haven't told the subjects what to do yet on the screen, and so what we can do is we'll start off by putting that information in. Okay, but the other thing that we have to do is also include some way of going through all 4 of those blocks all at once. And as I alluded to previously, okay, we can do that using a nested loop. And so what I'll do is I'll just delete all this. Okay, this is me practicing before. We'll save that. So we don't need to import anything else from our Python, from Psychopy or Python. But essentially what we need to do is we need to run a loop for 4 times. Why 4 times? Well, it's going to be block 1, and then block 2, and then block 3, and then block 4, right? And block 1 will be shorter or longer. Block 2 will be the opposite, shorter or longer, and then block 3 will be shorter or longer, and then block 4 will be shorter or longer, okay? And we interchange that. And so we need a loop that will run for a total of 4 times. And we know how to do that. We'll just say, okay, for P in range, say 4, okay, then we'll do something for 4 times, okay? But what we can do is we can set up here a variable that says, let's say experimental task, something like that, and we'll make it an empty array. And remember, empty arrays are items or elements that are separated by commas. And what we'll do is we'll say shorter, and then we'll say longer, not logner, and then longer, and then say shorter, and then something like this, longer, okay? And so therefore here we have the first experiment being shorter, the second block will be longer, and then the third will be shorter, and then the fourth will be longer, and they're counterbalanced, okay? We can randomize the order here using a similar way as what we randomize our stimulus presentation and our line links. But for this sort of thing, we can probably just leave it at experimental task and just hard code this for this level. And so for this program. Now, instead of saying for p in range 4, what we could say is for p in range length of experimental task. And so if you wanted to do 6 now, so 6 blocks, so you wanted something else and then something else there, then this loop here will now run for 6 times because it's basically being told to run for as long as the number of items in that array there. The reason why we're also going to put this array in here is because what we'll do is we will print out what the current task is. Okay, so print, okay, so current task is, and then we'll put %s, oops, not capital S, %, and then what we'll do is we'll index into that experimental array. So exp task. So what we're going to do is we're going to go into this array here, okay, and we're going to say, okay, if p equals 0, so the very first time that we did that, I've just noticed that I need a pop filter or something. But anyway, the first time we run this loop, p will be 0 because it instantiates to 0. And so we'll then go into the experimental task array at the 0th position, and so that will be at the pth position, and then it will print out shorter, okay? And then what we'll also do is we'll just print out, say, current block number is %d, because it's an integer, and then we'll just print out p, okay? So hopefully what will happen is we will go through something 4 times. The reason why it's 4 times is because we've got 4 items in this array, and then we'll print out the current task and the current block number, okay? So we'll run this again. So we're running this in our sandbox because we're just playing around and we don't care really what happens. So line sand. What I'll do is I'll just clear the output of the command prompt there, okay, and then we'll just run this. So line sandbox.py. So hopefully we'll see something loop through 4 times, but then it should say shorter, longer, shorter, longer. Okay, so when p is 0, it's going to go into experimental task array at the 0th position, which is here, and it's going to print out shorter. So the current task is shorter. And then it's also saying the current block is 0. Okay, so that's great. What we may have done, what we would have liked to have done, is put this the other way around, so then we can say, hey, look, we're in the current block 0, and so therefore we're going to do something, we're then going to run a shorter trial. Okay, so that's great. Now what we can do is we needed to run something 4 times, but then what we needed to do is we need to run the 40 trials, don't we? Because for each block we need to run 40 trials. And so as I alluded to before in the previous videos is we can make a nested loop. So we can put a loop inside another loop. And the way that we do that is to just indent across and then start with another for statement. We have to change the iterator now. And so we'll just say for I in range number of trials. And remember we had number of trials as 40. Okay, and then what we'll do is we'll print trial, current trial, something like that. And we'll do that, that's an integer, and so we'll do something like this for I. And so what's going to happen is we're going to initialize this first array. It's then going to go into the 0th position, okay, and say the current block is 0. The current task is, and it's going to print out shorter. Then once it's done that, it's then going to go into this loop here, and it's a whole new loop now, and so it's going to start at 0 and go from 0 to number of trials and then print out the current trial. And then once it's done all of this stuff in this inner loop, it's then going to go back out to this parent loop or the outer loop, and then it's going to increment its counter here. So p goes from 0 to 1, and so therefore current block is now 1, and so therefore the current task is, this is now number 1, and so therefore it's going to now read this. So the current task is longer, and then we're going to run into this inner loop, and then that inner loop is going to run 40 trials. But the task is now being bracketed by a longer statement. So let's see if this actually works. We've saved that blue circle is missing. And so we're going to get a lot of printout now, but let's just see what we've got. We'll go back up to the top. Okay, so this is where we just run the program. So the current block is 0, the current task is shorter, and then you see it's run 40 trials, 0 to 39. And then it says, okay, now the current block is 1, the current task is longer. So you see how we've gone from shorter to longer. So we started off shorter, we're now in longer, and then we're running 40 trials. Okay, so this is how we now control, and then trust me when I say that we're continuing on with our shorter and longer array. So what we can do now is we can put this parent structure into our main program. Okay, so if we have a look now down here, where we declare our variables, we'll declare now the experimental task, and we'll say that this is going to be shorter, and then longer, and then shorter, and then longer. Okay, that's great. And then what we can do is when we come down to our main program loop, so our main program loop goes here, we will then say, okay, for p in range length experimental task, we then want to do this. So now we've essentially got all 4 of our files. If we go like that, sorry, we've now got access to all 4 of our blocks here. Now we're going to have to think about how we're going to save, because now we're saving after every block, and so you may not want to do that. What you may want to do is just build a global array and then save that right at the end. So what we'll do is we'll try that now. So we'll put that at the parent indentation. Okay, and so now hopefully we should have the whole array. But what we will want to do now is we'll need to add into our Excel spreadsheet or into our data frame some understanding or some idea of what the block number is. And so what we'll do is we'll say, okay, after the time, we'll say something like block ID, and then that will be block ID array. Okay, and then what we'll need to do up here is we'll then need to put into here block ID array dot append, and from that we're then going to append the position. We'll just append into it p, because p is going to go from 0 to 3. Okay, and so what we'll do is we'll go p, because this p should be passed into here. We'll see if it doesn't, but it should do. Okay, and so therefore we've now extended our data frame to include the block ID, and so we should get now, hopefully at the end of this experiment, 160 trials with each 40 trials being incremented by the block ID. So what we'll do, this should hopefully run, okay, and so I will pause the video. I'll start the program. Let's start. I'll pause the program and then, oh no, sorry, I just ran line sandbox. Sorry about that. I'll pause the video, run the program, and then we'll see what we get out at the end. Okay, so we'll not run that one. We'll run line_task.py. Hopefully everything works. So I'll do the first couple on screen and then we'll see what happens at the end. Okay, so that's come onto this screen. So my name is AG, and we'll just call the name first. We'll just call this 001 underscore. Yeah, that will be fine. And we'll just make this as 10. Okay, and then yes, we will want to save into this folder here. Save, great. And so get ready, press enter to start, and so I'll hit enter now. And then, okay, block ID array is not defined. Oh, okay, because I haven't actually given it a block ID array, something like that. Okay, so I'm trying to append into an array that I didn't declare or create right at the start. Okay, so AG, and we'll just call this underscore 001. We'll just make this 11. Save. Okay, we'll see what happens. Press enter to start. Great. Okay, so there's the first trial, second trial, third trial. Okay, so I'll pause the recording and we'll come back later. Okay, so I've just run that and I came up with an error. The error was that there were different lengths of arrays that we were trying to save. Up here, if you have a look here, this was the output after I did those 160 trials. It took quite a while. And it said, hey, on line 334 in module, latency, response latency, and if we look down here, it said arrays must be all the same length. Excuse me. And so what I did was, I then thought to myself, well, what is it that we're doing wrong? We're obviously not passing in the correct number of entries or rows in each of the columns. And so what I did, when the video was paused, was I essentially commented out the file saving, so the creating of the data frame, because I just wanted to ask myself, well, how many elements are in each array that I'm trying to pass into the data frame, and looking at the magnitude of those numbers to see whether or not there is any sort of common error. Okay, so what did I do? I basically printed out a whole bunch of print statements, debug statements that said, okay, in the trial number array we have, and then we've given it the length of the trial number. And I did that for all of the contents of our data frame, or of what we want in the data frame. And when we have a look down here at the output so I did the experiment again, we can see that the trial number array has 160 elements, and that's good because that's what we want. We want 4 blocks of 40, and we go down to subject ID, 160, date, 160, time, 160. So these are all great. But then we look at the line length, and the longer side, we see we've only got 40. And so the fact that we've only got 40 means that we're only passing in 1/4 the number of items that we need to pass in. And so we can now zoom in and focus in on those two particular arrays and what we do to them when we try and save them. And so if we have a look back here at what we're doing when we create the data frame, so I'll just uncomment that, we can see that for what are the two ones? We've got line length and longer side. So line length here is the line length array, and that's only got 40 elements in it. And so if we have a look up where our line length array is, we can see that the line length array, random stim side, let's have a look here. So the line length array, we created for just one block of those 40, and then we're going to repeat that 4 times. And so and same as the stim side actually, because remember we create the randomized order of the stim side, and then we're just passing that directly into our data frame. So what we should probably do is, there's a couple of ways that we can tackle this. We can create a final stim side array, okay, and we can create a final line length array. And then what we can do is, instead of passing into our data frame the single block line length array, we could say final line length array, and we can pass in the final stim side array. But then what we have to do is we have to build them, and we'll build them exactly the same way as what we built them before. How we built the other ones. And that is, for every time we run into this inner block, we then want to append into it. So final stim side array dot append. And what do we append? Well, we append the current position of our stim side, our unitary array for those 40 trials. Okay. And for the final line length array, we'll append into that the line length array at the ith position. Okay, so hopefully that makes sense. So instead of just passing the array for a single block, what we're going to do is we're going to treat the line length and the stim side array like all the other arrays, and we're going to build them up trial by trial by trial. And so hopefully these guys here, the final stim side array and the final line length array, should now have 160 trials in it and not 40, because they're being built or constructed at the same time near enough as the other trials. Okay, so we'll give this a shot. What I'm going to do is I'm also just going to do a little print statement in here. I'll just say print current. This is just for me. When I do this off camera, just so I know how many trials we've got or what trial we're currently up to. Okay, so we'll start this. This should all work. We won't need to print all of this out again. Okay, so I'll just comment this bit out now, but we'll leave it there just in case. Okay, and we'll see how we go. So we'll run the line task again. I'll do the first couple of trials. I'll pause the video and we'll see if we've made any mistakes. Okay, so have I run that? What have I done? Yep, just taking a little bit of time to think about what was going on. AG001, and we'll just put Methuselah. Okay, great. That will come up then with a save. Yep, that's fine. And then get ready. Press enter to start. Hit enter, and okay, so that was one. I'm just going to push random buttons here because the task, we don't know what task we're doing yet. We're going to do that after this. Okay, so I'll pause the video and we'll get back. Okay, so how did we end up? That took a fair while. According to Kim, remember, it took the subjects about 7 minutes to complete. So I've done all the trials. You can see I used those print statements to just give me some idea of whereabouts in the program I was. And so if we have a look now using Atom, the folder overview. Remember, we click on this sidebar here. We can make that wider and shorter in Atom. We can see that we've saved a file now, AG_001_11 line task, and you can see here we've got a preview here, and it looks pretty good. It sort of has all of our columns separated by commas, and that's how we've created our save file. And then if we have a look at our spreadsheet here, we now have, I'll make this just a little bit bigger for you. Okay, that's way too big. All right, so as you can see here, I don't know if that did anything. Hey, I've gone up to 129%. Click. You can see now we've included the block ID, and so this should be, the first block should go from 0 to 40, and so here we've got 2 to 41, so yep, we've got 40 trials in there, and then that block ID then cycles up to 1, and then it goes to 2, and then it goes to 3. Okay, so all in all we should have now 160 trials, and we do. Okay, it says 161 there, but remember we start not at 1, we start at number 2. Okay, so that's great. So we now have a complete and entire experiment. We can do all 4 blocks, and each of those blocks excuse me, now the order of the stimulus presentation and the line lengths are the same for each of those 4 blocks. And so if that's going to be a concern for you, i.e. you want every single one of those blocks to be randomized, the order, then you'll have to shuffle each of those every time you change the blocks. It shouldn't be too much of an issue, but you could probably do that by putting in your, if we have a look here, where we create our shuffled, okay, we can shuffle them, Control C, inside our main loop. Yeah, something like that. Yeah, the birds are quite loud today. They must be hungry. I don't know what they're doing actually, I'm not a bird. Okay, and we can put this random shuffle in here, and so this should shuffle, okay, the order for each block, okay, and only at the start of each block. All right, it's not going to change what happens in here, because remember this loop, this inner loop here, which is calling out each individual trial, it's not randomizing it on each individual trial. Wow, that was really difficult. What it's doing is it's going into the newly shuffled array, which is only shuffled when this outer loop changes, or is called, or is updated, okay? And so here, this should shuffle the order for each of your blocks, and so therefore you won't get any sort of biases, or you reduce the likelihood of biases creeping in. Okay, we'll push this back to the left here because we don't really need that now. Okay, so here you've got better randomization, and all we've done is we've just shifted that random.shuffle inside the outer loop. Okay, so what next? What we can probably do now is at the end of each block, okay, we might want to just give our subject a little rest and just say, okay, for this block, we want to do longer, okay? And so what we'll do right at the start is we'll say, press enter to start, okay? And then what we'll do is we'll have another text info, and text info.draw, and then win.flip, okay? Let's just control C that. And then what's going to happen, okay, is we will, oh, I didn't cut that, hang on. Let me just try this again. Command C, and then Command V. Geez, I'm not having a great day today. It's all right. It's only a Monday. It will get better. We did it. Okay, so update the subject on what task to do, longer or shorter. Okay, so how are we going to do that? Well, we've got pressed enter to start, and we'll say, okay, we will say something like which side is, okay, and then after that we'll add into that a string, okay, and we'll put into that exp task p. Oops. Okay, so what are we doing? I'll just make this so we can see it a little bit easier. Okay, so we're basically, remember we've got our, right up here, we've got our experimental task, shorter, longer, okay? So this is the array, and we're using the length of this array to tell us how many numbers of blocks we want to do. And so in this case, it's going to be 4 blocks. And so when we create our main program loop, our outer program loop, we are basically looking into that experimental task array, and we're going to pull out the first, well, the 0th position, okay, and then pass that into here. Okay, so this text info, visual.textIm will only update, or it will update, every time we increment this outer loop, and then it's going to present that onto the screen. And this is going to be this will update every time p increments, and it's going to shift one more position on that exp task array, so the experiment task array. Okay. And so what we can do is, instead of putting that position at -200, what we'll do is we'll put it at 0, 0, and then underneath that, okay, we will pass in a press start to enter. Okay. Press enter to start. Okay, and we'll put that down at -200. Okay, and then win textinfo.draw, win0.flip, and then we'll just put an event.wait keys max weight equals 99999. We'll just press any key. Okay, so this should hopefully now update, this should now inform the subject, hey, what do we want you to do for this particular block? And it will also give the subject a bit of a chance to rest between each block, just in case they need a bit of a timeout, if they're feeling a little bit overwhelmed, or if they just need to, I don't know, recoup their senses, I guess. All right. And so let's run this program. We'll shift this back across there. Look, we're pretty much done now in terms of our experiment. So we'll just run this and we'll see if there's any errors coming up. If there's no errors coming up, then look, this is our program. We can tidy up a fair bit now. We can chuck a lot of stuff into functions and just get things to look a little bit better. And we also do need, remember, we have that little bug, we'll call this 002. We do have that little bug that could possibly come and bite us on the bum. That's where if we hit cancel in that first dialog box, it will still continue. Yep, we'll save that there. That's not a problem. So now hopefully it should say, press enter to start. All right, so this is, you would have this all showing when your subject comes in, and you would give them the spiel, and then you would get their informed consent, and then when they're ready, they'll hit enter to start, and then hopefully something happens. All right, list object is not callable. What have I not done? I think it's because what I'm trying to do is not do that, but I should probably do that, so square brackets there. Okay, so informed consent, and then get them ready, get them started. Sorry, I zoned out there. I was thinking of what else it could have been. Okay, that's fine. We'll just save in the same spot again. So hopefully it works now. Okay, which side is shorter? So that's off to the side a bit, so we'll need to shift that back across. And then also, yeah, we can't see that bottom thing. Okay, so we'll need to change the position there. Okay, and so therefore, here we go. We are now running the experiment. And again, I will pause the video because, actually no, we don't need that. Which side is longer? Okay, so when I hit Q then, what happened? It broke out from that middle array, sorry, that middle loop only into the outer loop. Okay, and so now we have to figure out a way of breaking out of both loops. Okay, because now I have to push the Q button 4 times. Okay. And so how are we going to do that? What have I done here? Minus 200 pixels, press any key to start, height, units, position 0, 0, align horizontal left. I wonder what's going on there. Minus 200. Oh, okay. I've changed the X position, whereas I need to change the Y position. Okay. So the X position minus 200, 200, so we want that, say minus 100. We'll put that at 0, 0. Text info, press enter to start. That should be... we'll just leave it at that. You can sort that out at your own time. We'll get stuck. We'll get stuck somewhere. Now, how are we going to break out of both of these loops at once? Because remember, what we've got here is we've got this inner loop, okay, for iron range. We don't need this anymore. And remember, this loop will run for the individual block. Okay, and so what we need to do is we need to, when we break out here, we need to somehow break from here into here. And so what we can do is we might be able to do something like set a break flag equals 1, and then at the end here what we might do is you might say if break flag equals 1, we'll break out of there. Okay, and so this break flag here will only be 1, okay, if we hit the Q button at any time. And then it will check because it will come from this inner loop into this outer loop. And so let us just set that break flag at the start, just so we can make sure that we will initiate the program. So break flag equals 0. And so let's see what we get. So the purpose of us running this program now is just to see if that Q button will break us out of both of those loops, the inner loop, the outer loop, and then back to the parent indentation. or the leftmost indent. So we don't care about this. We're not going to save anything. All we want to do is quit out of this. So save there. Okay, press enter to start. Great. Which side is shorter? Okay, great. And then we run the trials, and then I hit Q, and it's great. It's broken us out of all of that. Now it has, yes, given us this error, because remember, the arrays have to be of the same length, and we're not giving it the correct length arrays. All right, so that error was totally expected because we haven't populated our data frame correctly. Okay, so that's pretty much it. What I'm going to do now is just clean up this text here. The reason why we can't see it is because we're not drawing it. Andrew, silly Bill. Okay, so here we go. Now we should be able to see it. Let's see what we get. And I was willing to just gloss over that problem. So always draw your stimulus into the memory, and then flip it onto the screen. Draw, flip, draw, flip. I made that point so clearly about 4 videos ago. Yeah, mong. Right, let's see what we get. So press enter to start. Great. Okay, which side is shorter? Press any key to start. So there we go. We've got now the subject instructions, and you can clear this up and clean this up whichever way you want. Okay. Right. Press any key to start. That's fine. They can hit whatever they want. We'll hit Q because we don't need to do anything about that. All right. What's that? 36 minutes 52 seconds. Right. We're going to leave this video here. You now have a working program that will run all 4 blocks. It also now includes your instructions to your subject, and it will also save all of the trials in a single Excel spreadsheet, or into a file format that can be read with Excel if that's what you use to analyze. It can also be read by SPSS. It can also be read by, we can also import it in Python or MATLAB, anything that you want to use to analyze your data. Now, the purpose of this video, or these videos, is not to teach you what analysis to do. Okay, that's in the Kim paper. You can have a look to see what analysis they did. If you are interested in that, then we can send me a message or comment to this video, and I can see what we can come up with. The point of these videos were to show you how to design and build and debug a psychophysics experiment, or a visual neuroscience experiment, using Psychopy and Python. Okay, so I think I'm done now. If you want to try and figure out how to get around that little bug that we've still got in that program, remember we've got this bug here that if mydog.log.ok, have a go at trying to figure out how to get around that. If you are struggling, or you want to go through how to get around that bug, again, comment, message me, and I'll chuck another video on. But I think for this stage, it should be okay. For the main program runs quite fine, and no worries at all. All right, so best of luck with your experiments. Best of luck with your programming. I hope this helped. It's been really fun programming it, and I will now have a think about what other experiments we can look into building and designing and experimenting and creating, and seeing what else we can do with our Psychopy and our pandas and our Python and whatever else we can bring along. Maybe some Arduino code, or data acquisition devices, something like that. All right, so best of luck. I'll see you in the next video.